Alrighty, everyone, we just got our okay to start our planetarium show. So for now, folks, I'll be putting away our space trivia questions up on the screen because now we're going to be heading into the unknown. Ooh. And good afternoon, everybody. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person. I'm standing right behind you. Hey, good afternoon, everybody. Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. I just want to let you know that I'm an actual person, and I'm going to be doing our presentation that we're about to see right now. I also want to let you know that everything that you see in purple is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for our projector system, it's hidden just below that purple glow. And also, folks, the show that we're going to be watching right now is one of my favorites. It's something that we just brought back not too long ago. This one's called Tour of the Universe, and this show is completely live. Pretty much with this show, we're going to be starting off pretty close to the planet Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis. But forewarning, you may... I just want to let you know that we're pretty small in the grand scheme of things. But before we get started, I do have to go over some quick house rules just so that we're all on the same page. First off, there's no food or drinks allowed in. If you manage to bring any snacks, make sure those are put away till the end of the show. We want to keep the theater nice and clean. Also, folks, if you have any cell phone smartwatches, now's the time to turn them off, put them away for the next 30 minutes, as these can be very distracting in our dark environment. It takes away from the planetarium show experience. And if you need to leave early, you're more than welcome to do so. All we ask is that you exit towards the top of the planetarium. That's where you're going to find the exits before, during, and afterwards. So always make your way up the stairs. If you have trouble climbing the stairs, don't worry. Just remain seated. Once the show's over, we'll have someone escort you to a lower exit as the show's wrapping up. And also, folks, lastly, if for any reason during the show you feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you got to do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. But with that being said, it looks like we're ready to go. And I want y'all to sit back, relax, and let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to our planet Earth. We're orbiting around this spacecraft right here called the International Space Station. We also like to abbreviate it as the ISS. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in news and science articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks. The International Space Station is a research facility. It's a laboratory that orbits around our planet Earth. And they conduct all sorts of science experiments up here that they can't really conduct closer to the Earth, which has a lot more gravity. So some of the experiments that they'll conduct are things like what happens when you try to grow plants in space? Do the plants grow differently with less gravity? Which way do the roots grow? Another one is what happens when you try to spark a match in space? Does the flame act the same? Does that act differently with less gravity? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compare and contrasted the 2 twins. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time. So if you plan to live in space for a long time, remember to exercise daily. And also, folks, the International Space Station here in our planetarium dome looks really, really big, but it's not that big in actuality. It's only about the size of an American football field. If you've never been to an American football game, you can also use the entire California Academy of Sciences, the museum that we're sitting in right now. That's about how big it is. And also, folks, this thing is going incredibly fast. The International Space Station's traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, it looks like we're really far away from our planet, but it's not too far in actuality. The International Space Station's only 225 miles above the surface of our world. 225 miles. That's not too far away. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. And to tell you folks, this is as far as we put humans into space nowadays because traveling into space is quite costly. You got to build yourself a rocket ship or buy yourself one. You have to get all that rocket fuel. And you also have to account for all the food, water, all the air you're going to be breathing while you're up here. But the International Space Station is just our starting point on our tour of the universe. So now we're going to see it slowly disappear and it's going to fade away to the landscape down below. And it looks like we're hovering just above Baja, California, so we're going to see the International Space Station disappear to the desert below. In fact, before we lose it, I'm going to add a nice little orbital path so we can keep track of it as we zoom away. Alrighty, folks, we've zoomed so far out now, we're now able to see our entire Earth in its entirety. And I want to let you know that the space program that I'm using in here is something that you can go home and download and you can play with as well. This one in here is called OpenSpace. So if you go to your favorite search engine, type in OpenSpace project, you'll come across the link where you can download this. But just a heads up, OpenSpace is uses a lot of processing power and requires a lot of storage. So if you have an older computer, you may not want to download it, but if you got something new or a gaming computer, give it a try. It's a whole lot of fun. But if you're a person like me that doesn't want to download anything, we also have another great alternative called NASA's Eyes, just like the human eyeball. Just type in NASA Eyes to your favorite search engine, and you can fly through space without having to download anything. But in here right now, we're using OpenSpace. But let's make our way over to our nearest natural neighbor to us in space now, folks. Let's make our way over to the moon. Now, just to let you know, folks, we humans have been to the moon before, but that was a little while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science up here, and of course, they had some fun. They got to play some golf as well. But again, the last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years thanks to NASA's new space mission called Artemis. Pretty much with Artemis, our technology has greatly improved in the last 50 years, so we're able to do a lot more science in a much more smaller, compactable size, so we can do a lot more stuff with a lot less equipment. And one of the things with Artemis is that they're going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon. But not only that, they're also going to be setting up lunar bases throughout our moon. The one place that we definitely want to set up a base is the south pole of the moon because we found ice there, and that's going to be very helpful because we can melt that ice, pass electricity through it, we can get oxygen and hydrogen. Those are both very valuable stuff when you're really far away from our planet. But again, we humans should be heading back to the moon in the next few years thanks to the Artemis space mission. So look out for any news about that in the coming years. And now, folks, I want to let you know that the moon is also incredibly far away. Sometimes it feels like it's really close here on Earth, especially when you see it right next to the horizon. It feels like you can reach out your arms and touch it. But the moon's about 240,000 miles away from the Earth. Whew. 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months, nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out there are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. Now, light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say bye-bye, moon. We'll see you later. So cute. And now, folks, we're going to see the moon and the Earth as they start to slowly fade away. In fact, before we lose track of them, I want to add some nice planet trails so we can see where stuff is all the way out here in space. And on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace, showing us the most accurate images and information available to us. And now the nearest star to us, the sun, should be coming into view any second. So here comes the sun. Do 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 do. And also, folks, the sun is also really far away from us. It's about 93 million miles away from the Earth. 93 million miles. Whew. But that's also about 8.5 minutes at the speed of light. Now again, light travels really, really fast. So in order for sunlight to travel all the way out towards the Earth, so the sun's right there, we got the Earth right over there, third rock from the sun, takes sunlight about 8.5 minutes at the speed of light to cross that 93 million miles. Now, this is a really cool concept because if the sun was to turn off all of a sudden, we wouldn't know about it here on Earth for about 8.5 minutes. And again, such a cool concept to grasp because let's say we're looking at a star that's 70 light years away from us. We're looking at that star as it looked like 70 years ago because that light that's just reaching us traveled 70 years to get to us. So when you look at really far away objects in space, it's kind of like looking back in time in a sense. Pretty cool. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what we have here. Right in the middle of our solar system, we have our sun. Closest planet to the sun, we've got Mercury. Then we have Venus, Earth, that's us, and then Mars. These are the rocky terrestrial planets. These are places where we can actually land a spacecraft on. And then past the orbit of Mars, we have this really cool thing called the main asteroid belt. And this is what it looked like with all those asteroids. There is a lot of them. And then past the asteroid belt, we have the really big planets, the gas giants, the Jovians. We've got Jupiter, the largest of them all. Then we have Saturn, famous for its rings. And then we have our icy gas giants after them. We've got Uranus, the funny one, and Neptune. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto. Just came on screen on the right-hand side right there. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt, past the orbit of Neptune. And you're probably wondering to yourself, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. So the Kuiper Belt is like a second asteroid belt way out here past the orbit of Neptune. And mostly what you're going to find out here are icy asteroids and short period comets. And comets that don't stray too far away from the sun. And we kind of came across this in 2006 because our telescopes and equipment became improved greatly, so we're able to see much smaller objects way out here in this outer part of our solar system. And we found a whole lot of stuff out here, more than 400 objects. So we couldn't call all this stuff planets, so everyone on Earth came together, had a great big meeting, and they made a criteria of what you need to be a planet. And unfortunately, in that meeting, they demoted Pluto from being a planet. So as of 2006, Pluto is now considered a dwarf planet because of the Kuiper Belt. We came across all this stuff. There's so much stuff out here. And that's the cool thing about science, because as our technology gets better, we're able to see much smaller stuff much further away, and we're learning that there's a lot of things in our own solar system. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now, folks, I'm going to be adding on screen some of the many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which flew by Pluto in 2015. Now, all these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes light about 5 hours to travel this distance. 5 hours, not too bad. But folks, let's leave our planetary scale behind us because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And it looks like Alpha Centauri is going to be right in our foreground, just right in front of us. So again, we're right in the middle. That's our solar system. Alpha Centauri just right in front of our view, right there. And again, 4 years at the speed of light to get to the next star system for us folks. But that doesn't really put into perspective of how long it would take us humans to travel that distance. Well, folks, if you're getting a rocket ship today, left planet Earth, made your way over to Alpha Centauri, it's going to take you about 8,500 years to make that distance, make that travel. And that's just a one-way trip. Whew. But folks, let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. And again, folks, we're now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. Now, this first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are all traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year, so is anybody out there listening? And now, folks, I'm going to be adding some many markers onto the screen. These markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that 5,000 number is going to be going up as the years continue, because we have spacecrafts where the whole purpose is to find as many exoplanets as possible. So that 5,000 number is going to be going up. Now, to say if any of them are Earth-like with conditions suitable for life, well, we can't answer that question quite yet. Pretty much new spacecrafts are being developed right now, so they're on the drawing boards. They got to be constructed and they got to be launched into space. So we got a little while before we can answer that question. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system on the left-hand side of our radiosphere. Let's say this one over here. We find an alien civilization somewhere towards the middle, let's say over there, and we shoot them a text message. We say, hey, we're humans. We live on Earth. It takes 60 years to get to them. They listen in, answer back. Takes another 60 years to get that message. Folks, that is a 120-year conversation in the making. Whew. And I can barely wait for a text message from my friend. And of course, folks, planetary systems beyond our radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, folks, I'm going to be putting away our exoplanet markers away, but I'm going to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. Alrighty, everybody, we zoomed all the way out, and we're now able to see our entire galaxy, our Milky Way galaxy. And I've got to ask, can anybody see their house from here? Just kidding, we're way too far away. And folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light just to cross it once. And our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I want to show you what it looks like from a sideways perspective. You're going to notice that our galaxy looks like a big flat pancake. Now, this is important because you probably heard someone say, hey, look, you could see the Milky Way from here while you're camping. What you're looking at is the plane of the Milky Way. That's what you're seeing up in the night sky. And also, this is important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south instead of looking to the plane of the Milky Way, because we have a bunch of planets, stars, gas, debris, black holes, things that block their view of the universe. So again, it's a lot easier to find galaxies and stars outside of our own by looking galactically north and galactically south. Keep that in mind. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of the many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group which contains about 30 galaxies large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy. Only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as our picture starts to expand, folks, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, they like to clump together in large groups and clusters, or they like to avoid each other where there's great voids, where there's very few or no galaxies. So we can see a nice galaxy cluster towards the middle right over here. We can see some clustering over there on the right. We can see very few galaxies towards the top left of our dome. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, this picture that we're now looking at represents the closest 30,000 galaxies to us in space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brantoli, who worked at the University of Hawaii, who compiled this amazing representation thanks to the work of other dozens of astronomers working aside him over decades of time. So big shout out to Dr. Brantoli and his team. But now, folks, we have automated systems that are even mapping the most distant galaxies. So now we're about to see the very large-scale structure of the universe. And remember, folks, every single point of light that you're now seeing, that's not a star, that's an individual galaxy. Whew, I feel pretty small. And just to let you know, our large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned we live in a big flat spiral disk of our Milky Way galaxy? Well, if you were to line up our Milky Way galaxy, it would go right up and down the middle, just like this. Now, scientists, and again, we like to look galactically north and south instead of looking through the plane of the Milky Way, but scientists still want to make sure that there was galaxies through the plane, and so you'll notice this purple survey of galaxies right in the middle. You'll notice that we're still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to fill in all these areas that haven't been mapped out yet, so it's just a matter of time. But let's continue moving on, folks, because we're running drastically low on our time of the universe. 30 minutes is just not enough. And as we continue zooming out, folks, we're now going to be encountering these really distant, faraway objects known as the quasars. And the quasars are going to be represented by these nice orange dots on either side of the large-scale structure of the universe. And quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away, so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe, and what we're looking at is something called a cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe that we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And this picture is a baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, with the lighter areas corresponding to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely, extremely tiny. They vary no more than 1 part per 100,000 in difference. But eventually, they gave rise to that large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, and that's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. This looks like a good spot. And let's make our return trip back to planet Earth, everyone. Alrighty, everybody. All right, folks, we're now crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I want you to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But hey, look at that, we made our way back into our Milky Way galaxy. We headed straight through that radiosphere, and we're now making our way back to our star system, our solar system. And now we're approaching those spacecrafts we sent on the 1970s to explore our solar system, passing the orbit of Pluto and the Kuiper Belt, and making our way to the third rock from the sun, our homeworld, planet Earth. All the people that we know, we love, everybody we've ever learned about in history, all lived on this one planet. And it looks like we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space, folks. And as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show today. And I want to thank y'all for stopping by and tuning in and checking out the show with me today. I hope you did enjoy it. But hey, look at that. We made it back to planet Earth safe and sound, just in time for dinner time. And with that being said, folks, that's all for today. Thank you so much for stopping by, and I hope you had a great time.